In Part 4, we will address some of the safety issues and how they affect installing renewable energy systems in the home. It's important to remember that standards are a moving target and vary from region to region. It's a good idea to familiarize yourself with the local standards prior to selecting which type of equipment you are going to purchase. Electrical installations must comply with the National Electrical Code in the USA and in Canada, the Canadian Electrical Code. In Canada, the code is published by Canadian Standards Association. You will often see the UL and CSA logos on electrical equipment. UL stands for Underwriters Lab and is a product safety testing and certification organization. CSA is a standards organization that develops standards in Canada. Europe also has its counterparts. The types of equipment that I will discuss in this video relate either to performing maintenance on the equipment or protecting firefighters. Firefighters and maintenance repair personnel need to be able to disconnect the AC from the inverter. The AC disconnect is located between the inverter and the utility meter and must be close to the meter. Since our houses have been wired for AC for many years, there are many AC disconnect switches available, even at your local hardware store. This one is from Eaton. DC disconnect is another safety product that stops the DC current flowing from the panels to the inverter. A solar system must either have DC disconnect as an integrated part of the inverter or have an external one installed near the inverter. Microinverters do not have DC current flowing down the house wires, and therefore a microinverter system does not require such a device. Here's an example of an external DC disconnect switch from Eaton. Rapid shutdown is another safety requirement. Even with AC disconnect and DC disconnect switches engaged, the panels and the cables can still be live with a high DC voltage when the sun is shining. When a firefighter needs to put an axe through the roof, they want to be able to do so without risk of electrocution if they should cut through a cable. To address this risk, NEC has updated the rapid shutdown requirement for 2019, requiring module-level rapid shutdown of solar systems. This means that the system will need to automatically detect when the AC disconnect switch is engaged and rapidly drop the voltage. In 2019, when the new requirement goes into effect in certain jurisdictions, all conductors 1 foot away must be 80 volts or less in under 30 seconds of the rapid shutdown initiation. Microinverters do not need a rapid shutdown, as this is already integral to the microinverter. This is because microinverters need to have an AC signal always present in order to function. So whether the grid goes down or AC disconnect is engaged, the system goes down instantly. The last system that we will look at is arc fault detection. Arc faults occur when loose or corroded wires have a poor contact, causing the electrical current to arc. This arcing can cause the wires to overheat and the melted wires can drip onto the roof, causing a fire. Arc fault detection systems are designed to detect this arcing in a system and shut the system down to prevent accidents. NEC code requires arc fault detection devices to be installed in DC solar systems above 80 volts DC. Solar systems can have 600 volts DC on the wires, and at that voltage can easily arc. Since arc fault circuit protection only applies to systems with DC voltages above 80 volts DC, microinverters do not require arc fault detect because they convert the panel DC to AC immediately at the panel. The DC voltages never reach above 80 volts. One important issue to be aware of is these devices can trip even when there is no arcing. The device can falsely detect an arc and shut down the system, which must then be turned on manually. Thanks for watching.